Welcome to homework.
All right, we're asked to consider the synthesis of Safrole, which has the following structure. There. From catechol, which has the structure. So how might we begin to determine a synthesis of Safrole from catechol? Well, to begin with, we can predict that it might involve some sort of electrophilic aromatic substitution, given that that's one of the main ways we're aware of how to add functional groups to benzene. So we could begin there. And then the other thing we might consider is that these two oxygens have been joined by a carbon. This could be perhaps the result of, for example, if we follow a retrosynthetic path here, we consider the breaking of just one of these bonds. One could imagine having begun with a product that looks like I broke the wrong side of the bond. Let's try that again. Bromine. Right, we might expect that an SN2 reaction could occur between this oxygen here and this carbon. Okay, now we can consider breaking another bond in a retrosynthetic path. What if we broke this bond? This might imply that we started with, I guess I should draw the rest of this molecule in. Here. All right. Something that looked like this. Dibromomethane. All right. Now let's consider another bond that we could break here. What if we broke this bond? What could this be made from? The component parts. Catechol. And given what we know of electrophilic aromatic substitution, we might expect that this product looked like something like that. Now this would have first implied that we had a carbonyl attached to this carbon. So we'll have to come up with some way of reducing that and taking care of it. But the general outline for our forward synthesis is fairly clear after having followed our retrosynthesis. The only thing that's not entirely certain at this point is, do we want to add this functional group before or after we've converted the catechols, alcohols into this sort of acetal structure here. Given that, to go from what was likely to be an intermediate product, let me draw that full intermediate product here. To get from here to here will involve a reducing agent. And if we're worried about these oxygens here or these carbons being reduced, then we may want to attach this functional group and reduce it after we've converted these alcohols into the less reactive acetal form. That is, the fact that we have to reduce a carbonyl tells me that we should likely convert these alcohols into their acetal form before we attach and reduce this functional group here. So from the top, we'll start with catechol. And react with dibromomethane. To yield this interesting acetal. Then we can take this acetal, or really now we're interested in the reactivity of the benzene ring, and do a Friedel-Crafts acylation. So we need aluminum chloride as our Lewis acid. And we're going to want the following acid chloride. This would yield now we have to consider which carbon this is going to add to when we do electrophilic aromatic substitution. The way I like to do this is say that this oxygen is partially negative, so this carbon is partially positive, which means this carbon's partially negative and this carbon's partially positive. So this carbon is the most likely position for electrophilic aromatic substitution, or this carbon, because they're equivalently, if you go negative, positive, you also end up with positive here. So it's entirely likely then that if we do proceed with the Friedel-Crafts acylation, that we will get electrophilic aromatic substitution at the carbon that we want that to happen at, which is good. So now all that's left is to add a reducing agent. But I will note that we've got to be careful about what reducing agent we add, because we want to retain this double bond here. If, for example, we used hydrogen over palladium, what we would end up with would be this product. We'd lose our double bond and our carbonyl. That's not what we want. So if we use a more mild reducing agent, such as zinc and mercury, we can reduce the carbonyl without losing our double bond. and thus we've arrived at the product that we wanted to arrive at. So reviewing, we used retrosynthesis to determine how we could end up with an acetal and how we could have added this prenyl group, and in the process determined that the order we want to do things in was to create our acetal first and then use electrophilic aromatic substitution to do Friedel-Crafts acylation and then reduce the product of that Friedel-Crafts acylation. So in the forward direction, it was reacting with dibromomethane or dibromomethane, followed by Friedel-Crafts acylation, followed finally by a reduction of the carbonyl.